In this video, we are going to take another look, a little bit more of a detailed look with some examples on types of frequency distributions, just as a review once again. So a very common distribution that we will see time and time again is what's called the normal distribution. And this refers to a set of data that are distributed in a very symmetrical kind of way. And this is typical of very, very large sample sizes that have this type of pattern or populations. We have along the x-axis a score, which is our dependent variable. And note that this is the only time the dependent variable will appear on the x-axis. We have the two far ends of the distribution on the right-hand side and the left-hand side, and that's what we refer to as the tails of the distribution. And the far lowest score and the far highest score difference represents the range. Now, the single highest point in the distribution is what we typically refer to as the mode, and that's the dependent variable score that occurs most often. And this coincidentally happens to be the same point where the median of the distribution of the sample or population and the mean of the distribution for the sample or the population will reside. But with the normal distribution, it can also take on different shapes. So we have what's called the kurtosis, which is a description of the normal distribution that is either very narrow or much flatter. It's still symmetrical, but it refers to the distribution of scores relative to the middle. So what we have on the top end is a normal distribution that is more what's called leptokurtic. And as a kurtosis value, it would take on a positive value. And in this type of distribution, as we see, here we see it's much narrower and the scores are much closer to that middle part that divides it up into both halves. So the scores are clustered closer to the mean. The mesokurtic is technically the normal distribution that has not changed its shape, and its kurtosis value would be 0. The platykurtic distribution is one that takes on a negative value, and we see here that it has a flatter appearance, and in this type of distribution, scores appear much further from the mean. There are generally two types of what are called skewed distributions. There are two tails to the skewed distribution, but only one tail is particularly pronounced. And this gives us an indication of asymmetry. And so we don't have mirror halves to a distribution of scores. And so here we see a very, very prolonged tail. And most of the scores are distributed on the right-hand side. So this type of distribution is referred to as negatively skewed. And I'm going to use the example here of running speed at the Olympic Games. So a negatively skewed distribution is one where the very long tail is pointing in the negative direction. And it is a result of the large number of scores, the very few number of scores on the very low end. And so the negatively skewed refers to just that, relatively low number of extremely low scores, remembering that our dependent variable, in this case running speed, is along the x-axis, and the number of people demonstrating various running speeds is depicted along the y-axis. And so the example here, as I mentioned, if we examine running speed in a track and field event at the Olympic Games, the 800 meters, we see that the majority of the runners at the Olympic Games for this event have very similar, not exactly the same, but similar running speeds clustered around the average. And this is particularly notable for the Olympic Games because of what's called Olympic qualifying standards. And so in order for runners to qualify for the Games, they have to achieve a certain performance in run-up meets prior to the Games. But what we see here on the very less pronounced tail on the right-hand side, we see a very small number of very high, very fast running speeds. And if we track this all the way over to the y-axis, we see that only 3 runners are clustered with this very fast running speed. Why 3? Because those are the Olympic medalists on this far end. So in order to win an Olympic medal, 3 people have to clearly distinguish themselves along the x-axis from the rest of the distribution. The other skewed distribution that we see here is what's called a positively skewed distribution. And in this case, the very long pronounced tail is heading in the positive direction. And so in this study, we're examining household income. And the positively skewed distribution refers to a relatively low number. Okay, so number is the key thing here, of extremely high scores. That is the basic definition for a positively skewed distribution. And in our example of household income in Canada, we see that the vast majority of households in Canada report an income that is clustered around the most commonly occurring household income, which is the highest point, which we defined earlier as the mode. But as we move along the tail here, move into the very pronounced tail of household income. So as we go from left to right, we see higher and higher and higher household incomes. Now, when we get to this narrowed part of the distribution, heading into the tail, what we see here are a classification of Canadian household in the millionaire category. And if we pick the middle part of this and we trace it all the way to the y-axis, we actually see a very few number of households that fit this category. Whereas if we track the mode of household income, which is much, much lower than the millionaire status, we see a very large number, or the largest number of Canadian households at a much lower household income. If we continue to travel along our tail, at the very far right, here we see our billionaires. And the billionaires are 3 orders of magnitude greater than the millionaires. But if we track this point in the distribution over to the y-axis, we see that in terms of household income in Canada, there's a very small number of households that would be classified in the billionaire status, much less than the millionaire status, both of which are considerably less than household incomes at a much, much lower level. So this ends our video on a review of skewed distribution.